so we're going to go ahead now and talk about systems of equations. Now, systems of equations, they can have more than two variables, but we're going to look at two variables. And when we talk about systems of equations, there's two variables, and these are lines. So what can happen is three different things here. You can have two lines that look like this. You can have two lines, and here's two lines, and we're going to find out where these lines intersect. That's what we're going to be doing. It's going to be an ordered pair. So that's what we've got, is we've got two equations, and they are going to be lines. Two equations, two variables, they're lines. And this has one solution, because they cross at only one spot. You can also have no solution. And how would you have no solution? Well, that would mean they never cross. And so when we look at two lines that never cross, these are parallel. Because remember, parallel lines are never going to cross. So this would have no solution. All right, so this one would have no solution. And then you can also have, for the last part, you can have an infinite number of solutions. And that's where these lines are on top of each other, where they're the same. Because you can have them look different, but actually be the exact same line. Because they can be directly on top of each other, and these that cross at infinitely many places. So this has an infinite number of solutions. Okay, because they're directly on top of each other. So these are our three things that can happen graphically. Is you can have one solution, which most of these are going to have one solution. 99% of these are going to have one solution. They can also have no solution, because in no solution, what these are is these are parallel lines. Because remember, parallel lines, well, they never cross each other. Or you can have two lines that look different but are the same, and that's like an identity. There are two ways to solve these. There's one way which is called substitution, and there's one way which is called elimination. And I'm going to show you both ways. Now, to do these, I'm going to create one, and I start with the answer. And so then we're going to solve the equation to get the solution. These are going to have a solution. So we're going to solve, and we're going to solve these with substitution. So this is going to be a pretty easy one. Now, I made this up by coming up with a solution first in my mind, and then this built the equation. Now, what we've got is we've got two equations and two variables. We've got an x and a y, and we're going to learn first about substitution. Now, when we solve these, our goal is to get it down to one variable, so we can find that variable, and then get the other variable, because we have to have it as an ordered pair. Now with this one is pretty easy, because we've got it solved for x here. So we know x equals 2y. So I'm going to take that x equals 2y, and I'm going to plug it in for x up here. So I'm going to take that and I'm going to plug that in for x. So when I plug that second equation into the first one, I replace that x with 2y, and then we still have the plus 3y, and that equals 5. Okay, so I substituted the second equation into the first equation. And now look at what I've got. Now I've got this down to one variable. So we can find the value of y. Add those together, and we get 5y equals 5. We'll divide by 5, and now we know that one of the variables is, when we divide, 1. So we now have the y component. How do we find the x component? Well, now that we know the y component, we take it, we plug it back in. And so I'm going to plug that y equals 1 back in. Now you can plug it back in anywhere you would like. I'm going to plug it into the second equation. And so now we can find x, because x equals 2 times 1. So x equals now 2. And what's our answer? Our answer is an ordered pair, x, y. And we've got 2, 1. So that's our answer. So you just substitute one equation into the other equation. And this is called substitution. Let me come up with another one here. Let's say, let me make this equal 4. So that equals 4. And I'm going to plug a value in for the other. And this is what it should be. So let me plug this in and see what we'll get here. Okay, so we're going to go ahead now and try to solve this system. And this is what eventually our answer is going to be. When I build these, I build from the answer backwards. So we're going to go ahead now and solve this system of equations. So we have two equations, right? And we have two variables. And this again is substitution. So we're solving by substitution. What we need to do is we need to solve for a variable in one of the equations so that we can plug it into the other one. And we want to make it as easy as possible, and we want to avoid fractions. So when we solve one of these, we can either solve the first one for x, because that's going to avoid fractions, or we can solve the second one for y. It doesn't matter, and we'll plug it in the other equation. So we need to solve for one of the variables in one of the equations. So let's just take the first equation and let's solve it for x. Right? It doesn't matter which equation we solve, we have to use both of them. And we want to really avoid fractions. I wouldn't want to solve it for y because I would get a fraction. If I took that first equation and I solved it for y, you're going to get a fraction. And you do not want to have a fraction. You want to make it as easy as possible. So I'm going to take my first equation and I'm going to solve it for x. So x plus 5y equals 15. All I have to do is move that 5y over. And that leaves you now with x equaling a minus 5y plus 15. Okay, and I've used that first equation. You have to make sure you use both of them. So I took that first equation and I solved it for x. Now, once you solved it for x, you simply plug it back in to the other equation. So I'm going to take that and I'm going to plug it back into the second equation. So I'm going to plug in x into my second equation. And when I plug that x into my second equation, now I've got 3 times a negative 5y plus 15 plus y equals 4. And now what's going to happen when I distribute through? Well, I want to solve it because we now only have one variable, which is what we want. We want to be left with only one variable. So we're going to distribute that 3 through. And that's going to give me now a minus 15y. And 3 times 15, that should be 45. Plus y equals 4. We're going to combine those together. So that makes it a minus 14y plus 45 equals 4. We're going to move that 45 over. And that gives you a minus 14y equals now a minus 41. Okay, let's make sure we got everything right here. So make sure we wrote it all right. Okay, so make sure we did it right. I know that we did, but we're just going to make sure that we did it correctly. And it may come out to be a fractional answer. Probably plug something in wrong. Let's see. Yep, that should be 15. Let's see what we got. So we took this equation here. All right, we took it and we solved it for y. Yeah, it may come out to be a fraction. That's okay. We've got it for y. Now we're going to divide by that minus 14. And that gives me now y equals a 41 over 14. And I should have been more careful when I made it up. I should have checked both of them. But that's going to be your y part. Now, how do you find the x part? Well, you can take it and you can plug it back in. You can plug that y back in. Or you can solve it the other way. Do the substitution the other way. Let's take our value now and plug it back in. So we know now that y is 41 over 14. You can plug it back into either one of the equations and solve it. So I'm going to plug this back into equation 2. So I'm going to go ahead and plug this into the second equation. And we've got 3x plus y. Now what's y? 41 over 14. And that equals 4. We're just taking it and plugging it back in. Clear out your fractions by multiplying it by 14. It's going to clear those out there. And 3 times your 14, well, that is a 42. X plus 41 equals 14 times 4, which is that 56. We're going to move our 41 over with subtraction. And that gives you now 42x equals 56 minus that 41, which is a 15. Divide by your 42, and that's not going to reduce down any, I don't believe. Well, actually, it'll go down by a factor of 3, because you've got x equals 15 over 42. Those both have a 3 in common, so that's going to reduce down to be 5 over 14. So our answer then would be, as an ordered pair, our answer would be 5 over 14, comma, 41 over 14. So that's how you do substitution. Now, when you solve these, I'm not going to care if you use substitution or elimination, but I felt like I needed to at least show you substitution. So, on your homework, if you want to solve them all by elimination, you can do that. If you want to use a combination method, you can do that. Elimination, I think, is going to be much easier for you to see how they work. So we're now going to learn how to solve these by elimination, which I think is the much easier method, but I still had to show you substitution, because that's one of our outcomes. And when we solve by elimination, what we do is we're just going to add or subtract downward. And we'll start off with a really easy one. And then we come up with good whole number answers here. I'll try to make sure these are whole numbers. Okay, so make sure these are going to come out right. So that should be a 32, and the other one is going to be a minus 11. Okay, so this is what we've got here. So this is called a system of equations, and I made this one up to be very, very easy to work through, and I'm going to show you how to use elimination. I had to show you substitution, just because it's one of our outcomes, but I think elimination is a much, much easier way of working with it. Let me double check and make sure these are right before we move on here. That's 32. That's a minus 11. Now, look at what we've got here. Okay, we've got the x's and the y's. And the x's are on top of the x's, the y's are on top of the y's. And we've got two equations and we've got two variables. Now, what we want to do is we want to get this down to one variable. And I showed you how to do it a minute ago with substitution. And that was kind of hard, especially like the last one. Now, when we look at elimination, we might be able to just add down and make them go away. Because what's going to happen if I just add down here? Okay, if these are on top of each other, and what's going to happen if I just add down? Yeah, because the 7x will come down. But what about the positive 5y and the negative 5y? Well, positive 5 and negative y, they're going to cancel out, aren't they? Right? And look at what happens here. These, when we add down, they go away. And now we've got 32 minus 11, which is 21. And we're down to one variable. How can we solve it for x now? Divide by 7. And now we've got half of our answer. Because now we know that x equals what? 3. Now what can we do with that? Well, we have to find both of them. Okay, this is much easier than substitution. But I had to show you substitution because it's one of our outcomes. Once you've got the 3, you take that 3 and you plug it back into one of the equations. It doesn't matter which equation you plug it into. Just plug it into one of them. So I'm going to plug that into our first equation. So plug in that value of 3 there for x. So plug in that value of 3 for x, and then see what we've got left over. So if I plug in x equals 3, we get this. So we plugged into our first equation. So I have 12 plus 5y equals 32. I'll move that 12 over. And so now we've got 5y equals 32 minus 12, which is 20. We'll divide by our 5, and what do we get for our value of y? 4. And so what's our answer going to be? Yep, 3 as an ordered pair, 3, 4. No, and we're going to slowly increase the difficulty on these. Sometimes you may have to multiply one equation by something to make it work with the other one. But we always want to eliminate one of the variables. So let's do another one. And let me try to come up with something for us to solve here. How about we look at 4x minus 2y equals, we'll come up with the numbers here in a moment. Let's say we look at 3x plus 6y for the second one. Okay, let me come up with something. I'm going to plug some values in here. How about 5 minus 2. So I'll come up with the equation. This should be our answer. When I make these up, I always have to start with the answer, and then I'll make up the equations from there. So this way you already know. Now you won't know the answers, of course, but on these, I'm just kind of making them up. That way you got a good mixture of all the different types. And let me double check and make sure that these are going to work here. So that's 20. And you can also see how I'm checking them, because 5 times 4 is 20. Double negative makes that positive, so that's 20 plus 4, that's 24. See, it works in that one. That's how you actually check your answers. You just plug the values in. This one would be 15. 5 times 3 is 15. Minus 2 makes it 15 minus 12, which is then a 3. But you won't know that, of course, because we're going to have to find it. Now, when we look at this, we can't just add down again, right? Because if we try to just add down, it's not going to work out for us, because no variable would go away. Well, what we can do is we can try to figure out the easiest variable to eliminate. And the easiest variable to eliminate is probably going to be y. And why I say that y is easiest is we look at the variables, and we know that we can take 2 times something to make it 6. Well, what would we need to multiply 2 by to make it the 6th then? 2 times 3, right? Now, we want to make sure that they're opposites in signs as well. So we're going to try to eliminate now the y. You can eliminate either variable, but these have nothing in common. 4 and a 3 have nothing in common. And I would have to use a 12. I'd have to multiply both of them. So if I take my first equation and I multiply every single part of it by a 3, what's going to happen? If I do that, then see what that does is that makes it a minus 6y here, and that's going to cancel out with that one. So we're going to go ahead and do that. We're going to solve it by distributing that 3 through, and that gives us 4 times 3, which is a 12x, 3 times a negative 2y, that makes it a minus 6y, 3 times 24 gives us now a 72. We're going to keep the lower equation the exact same. And now what can I do? Well, now I have successfully made it so that when I add down, what happens to one of the variables? It goes away, right? And that's what we want. We always want to get it down to one variable. Doesn't matter which one you eliminate. You just want to get it down to one variable. So 12 plus 3, that makes it 15x. And we've got 72 plus 3, that makes it a 75. We're going to divide that by our 15. And now we know our x comes out to be 5, doesn't it? Right? Because 75 divided by 15 is 5. Now, once we've got 1/2 of it, how do we get the other piece? Yep, plug it in. Does it matter where you plug it into? Nope. Whatever's easiest. Always take the easiest route possible. So I'm just going to plug it right into my second equation, because that's pretty easy to work with. And so plugging that in, I get 3 times 5 plus 6y equals 3. So that's 15 plus 6y equals 3. I'm going to move my 15 over. And now I've got 6y equals now a negative 12. Divide by my 6, and what's my value of y going to be? Y is going to be negative 2. And does that match up with what it should be? Yes, because that's what we found it to be, or I made it up with. And we found it. And so what's your answer now? My answer is 5, negative 2. And that checks out because that's what I made it to start with. Now, of course, you won't have that at the beginning. You'll just be left with these equations. Let's do several more just to make sure we know how to do elimination. because there's a couple of questions like this on your final exam. And you can use substitution if you want, but substitution in most cases is going to take you longer to do. It's a more complicated process. Elimination is usually going to be the easier way. Okay, so we come up with the answer here. Times 5 minus 7, so that's 33. Minus 15 minus 6, that's a 9. We'll double check and make sure that's going to work. So that's 40 minus 7 is 33. 15 minus 6, that's a 9. So here's what we're going to do. We're going to try to solve this again. Now, we can solve it for either variable. We can either eliminate for x or eliminate for y. When we look at these, we want to look at the numbers, and we want to try to pick the easiest, smallest one to work with. And how I get these numbers is I look at the least common denominator. So I think of these as fractions. When I was clearing out fractions with the least common denominator. Now, when we look at the x's, we have an 8 and a 3. Do 8 and 3, do they have anything in common? No. So what would be the least common denominator of 8 and 3? They have nothing in common. So the least common denominator of 8 and 3 would be 24. So we would have to use a 24. If we look at the y's, what do they have? The least common denominator of 7 and 6, well, they have nothing in common. And I would have to use a 42. So which one looks easier to work with? You always want the one with the smaller numbers, so it looks like 8 and 3 is going to be easier. Our goal is to make sure that these x's, because we're going to eliminate for x because it's got the smaller values, we want to make sure that they are the same. And we want to make sure they are opposites in signs so that one variable is eliminated. Now, you told me that the least common denominator of 8 and 3 was 24. So what do I need to multiply 8 by to make it a 24? 8's got to get multiplied by 3. And what do I have to multiply 3 by to make it a 24? 8. Now, that's not going to quite work because this would be 24 and this would be 24, but they're not going to cancel because they're both positive. So let's make the first one negative. That way we get a negative 24 on the top for the x, a positive 24 for the lower one, and they're going to cancel out. So let's go ahead now and do that. We've got to multiply both of them. We're going to distribute through. And we're going to get our two equations that will add together and give you the value of y. So let's go ahead and do those. So 3 times 8, and it's a negative. That makes it a minus 24x. Minus 3 times minus 7. Negative and negative makes it a positive 21y. And then the numbers do get large, but that's okay because we have a calculator. 33 times a negative 3. That makes it a negative 99. What about the lower one? Multiply that 8 through. We get 24x. Those are going to cancel when we add down. We have 8 times a negative 6. That makes it a negative 48y. We have 8 times 9. Well, that's a 72. And now we're in luck because what's going to happen when I add these down? Well, when I add these down, the x's do what? The x's go away, right? And so now I'm left with 21 minus 48. So that's a minus 27y. And I've got 99 minus that 72. And that gives you, 99 is larger, negative, so that's a minus 27. Divide by our minus 27. And that gives me now y to be what? Negative. Negative makes it a positive. How do I get the answer that I want for the x? Plug it back in. Does it matter where you plug it back in? No, it does not. You can plug it in wherever you would like. So I'm going to take this and I'm going to plug it back in. Let's just plug it back into the original here. So we're going to plug in y equals 1, and we're going to use 3x minus 6y equals 9. We're going to use that because that's our equation here. We'll plug it in, and we get 3x minus 6 times 1 equals 9. So that gives me now 3x minus 6 equals 9. We're going to add our 6, and we get 3x equals now 15. Divide by our 3, and we have x equals now 5. And so what's my solution as an ordered pair? My solution as an ordered pair, they go x, y, would be 5, 1. Okay, let's do another one. Let's say 8x minus y equals 10. And how about 4x plus 3y equals, well, let's not use a 10. I've got to come up with the answers here. Let me come up with the numbers here. How about 3, 2? So come up with that. So that's going to equal 22 here for the first one. And an 18. Let me double check and make sure those are right. That one's right, so is that, because that's 12. Yep, makes it 18. Okay, so let's look at how we would solve this one. Now, we can solve it with elimination. Doesn't matter which one we want to eliminate. We can either eliminate the x or the y. Now let's talk about each one, how we would eliminate. If I wanted to eliminate the x, this one has an 8, and this one has a 4. And what's the least common denominator of 8 and 4? The least common denominator of 8 and 4 would be a what? Would be an 8, right? We're going to clear those fractions if you think about it like that. So if I wanted to eliminate the x, what would I have to multiply the second equation by? Can anyone tell me? Least common denominator is 8. So what's going to have to go out in front to get rid of that x there? 4 times what makes it 8? 2. Now, is that going to work for us? Not quite. Why not? Because that would give us an 8x and a positive 8x. Do we want them both to be positive? No, we want one positive, one negative, so I'm going to use a negative 2. And now we'll distribute that negative 2 through. If I distribute that negative 2 through, the first equation stays the same as 8x minus y equals 22. And that's what we want. If I distribute through down below, I get a negative 8x. That's going to work out nicely for us, because those cancel. And a minus 2 times 3, that makes it a minus 6y. And minus 2 times 18, that makes it a negative 36. Now, what's going to happen when I add these together? Well, when I add these together, the x's cancel, and I'm left now with minus 7y equals, we've got 22 minus 36, that's a minus 14. We'll divide by our negative 7. And negative over negative makes it a positive, so y is now 2. That's the first solution that we have. How do we get the other? We know what y is. How do we get x? We plug it back in. Does it matter where we plug it back into? Nope. So it's one of the equations. So we'll just plug it in here. So we're just going to use y equals 2 for our equation. And we're going to plug it into 4x plus 3y equals 18. So plug in your 2. And 3 times 2 makes it then a 6. Move that 6 over. And so 4x equals now, when we subtract, it looks like 4x equals 12. We'll divide by our 4, and now we've got it, because x is now going to equal what? 3. So what would our answer be as an ordered pair? Ordered pairs go x, y, remember? So our answer would be 3, 2. Let's talk about one that has no solution. So this one's not going to have a solution at all, because we still have to talk about the ones that have no solution and the ones that have an infinite number of solutions. So when I look at this one, I'm going to try to solve it. So what do we have? We have 8 and 16, or we have 3 and 6. Either way, we want to get rid of one of them. So let's just take our first one and let's multiply it by 2, because that's going to make that 16 here, and that's going to be a negative 16, so they're going to cancel. But it's going to be a little bit different when we do that. So when we rewrite these and distribute that 2 through, 2 times 8, that's 16x. 2 times 3, that gives you a 6y. 2 times 10, that is 20. The second equation looks almost the same, but now we've got something different. Because what's going to happen when I add down? The x's go, right? Y's go, and we get 0 equals what? 18. Can 0 equal 18? No. This is a contradiction. So that means we have no solution. No solution, or the empty set. And why is it a contradiction? Because 0 can't equal 18, can it? So that gives us a contradiction, or no solution. The ones that have an infinite number of solutions, they're very similar as well, but we have a different way of writing our answer. So we're going to solve, we'll do 2 of these, I think, and I'll make sure I get these set up the exact same way that your homework is. Yep, arbitrary x. Okay, yep, that's what we want. So we're going to go ahead and solve these out. Now, these are going to be an infinite number of solutions. So let's look at these. Okay, we're going to solve it the same way. So we can either work with a 2 and 6, or 5 and 15. Either way, we want to eliminate one of the variables. Either way, it's going to be using a 3. So we're going to multiply it by, first equation by a 3. But let's change our signs to make them cancel. So let's use a minus 3. So when I distribute that minus 3 through, I get a minus 15x. Negative and negative makes it a positive 6y. Negative and positive makes it a negative 30. But look at what's happening down below. The second equation stays exactly the same. And now when I add these together, what happens to all of it? What happens on the left-hand side? Okay, it cancels, it gives you 0, right? What happens on the right-hand side? 0. These are the same. So this is like an identity. These lines are exactly the same. So they cross everywhere, and they have an infinite number of solutions. And if it has an infinite number of solutions, there's a very specific way in which we write these. Okay, if it has an infinite number of solutions, what we do is we solve for y. So if it's an infinite number of solutions, we have to use what's called an arbitrary x. So we have to solve one of these equations for y. Doesn't matter which one. So I'm going to take that first equation, and I'm going to go ahead and solve it for y. So that gives you a minus 2y equals now a minus 5x plus 10. We'll divide by our negative 2. So you're basically getting this in slope-intercept form. And that gives you now y equals 5 halves x minus 5. And how you write your answer is this. X is arbitrary, so x is itself. And y, what is y? 5 halves x minus 5. Because what this is saying is it is saying these are the same and this is your line. If you took either one of these and you solved either one of them for y, you would get that line equation. So it's saying that these are exactly the same, and there's the line that goes with it. So x is arbitrary, but everything that's on that line is a solution. We're going to do one more of these. And then we'll talk about some questions on that practice. Fine. Make sure I doubled that correctly here. Yep, okay. So let's go ahead and try and solve this one. As you can tell, again, we're going to have to multiply, but all we need to multiply is by 2. Why not a negative 2? Right, then they wouldn't cancel, would they? So they have to be opposites in sign. So we're going to multiply it by 2. And that makes it then 10x plus 2y equals 2 times 17. It has to be distributed through. That equals a 34. Down below, we have a minus 10x. We have a minus 2y, and we have a minus 34. So what happens with these again? Well, these are going to cancel, and we get 0 equals what? 0. So this is like an identity, because these are the same. So if it's like an identity, what we have to do is we have to find that equation that it came from. So solve it for y now. So 10x plus 2y equals 34. We're going to solve this for y. We're just basically getting it in slope-intercept form. So 2y equals now a minus 10x plus 34. Divide by our 2, and we've got to reduce. So y equals now, when we reduce, minus 5x plus 17, right? Okay, because we solved it for y. Why are we solving it for y? Because they're the same. They're the same line, so we have to find that line. That's what we're doing. How do we write our answer? X is arbitrary. And everything that is on this line, which is 5x plus 17, is a solution. Okay. Now let's look at some questions on the practice. Fine. I am going to work the rest of these out after class today and post them in Canvas. And I'll bring a copy back on Monday as well. This way you can go ahead and start working on these. So we've got a few minutes. I'm going to look at a couple of these. Just as kind of a review, we'll cover some more of them then on Monday. But we've covered pretty much everything. But I'm going to pick out a few of these that I want us to specifically look at. And then we'll do a couple more of these on Monday. So how about we look at, we've done a lot of the system ones today and a lot of logarithms. But let's look at question 13. And this is on your practice fund. So it's in the back of that practice final, question 13. So what I want you to do on this one is I want you to graph it. Now I picked this one because we have to think about things. It's easy, and it's a concept question. When I made up your final, and your take-home final and your practice final, these are not going to be super difficult questions. They're more of checking concepts. Do you understand the concepts? So I want you to graph this. The important concept I want you to see here is that this parentheses are outside, right? So that square has to be distributed through. So if I were to distribute that square through, then I would get f of x equals now 4x squared, right? Now we've covered these last week when we started graphing these types of equations. What is the graph of this going to look like? Well, what operation is around that x? It's a square, so we're going to use the square graph, the squaring function. And what does the squaring function look like? Squaring function looks like that. And on your exam, you can use the back cover of your textbook. So you're not going to have to write down all of those graphs. You can use the back cover. So on your final, you can use the back cover of your textbook. You can use that handout over graphing that I gave you. You can use the notes, right? One page of notes, front and back, or a stack of note cards. So those are your options there. So let's think about how we would graph this. Where do we start at? Can someone tell me where we'd start at if I was going to graph this equation? If I was going to graph this, 0, 0, right? Why 0, 0? Because is there anything on the end? Nope. Is there anything inside the parentheses now? No. So I'm going to start at 0, 0. What is that 4 going to do? So I'm going to start here at 0, 0. Now that 4, it's not your slope, but it's kind of like the slope. So that means we're going to go up 4 and over 1, aren't we? Right? So we start at 0, 0. We know it needs to look like this. That's our goal. Goal is this. So we start at 0, 0. Now, from 0, 0, we're going to have to go over 1 and up 1, 2, 3, 4. So that's going to be right there at 1, 4. And I want to curve it so that it looks like that. Now, are we done? No, because it needs to make a U. So how do I get the other side? It's a mirror image, so I do the opposite. I go up 4 and I go back 1. So that makes it minus 1, 4. And now when I connect them together, there's my picture. And we've successfully graphed it. Let's look at another one here. How about we look at question 15. And we'll just keep working through these for about another 15, 20 minutes. I'm trying to pick ones I know that students sometimes make a mistake on or don't know what to do. So let's look at 15. Now they give you a picture for f of x, and what we want is we want y equals 2 f of x. So first off, we need to take a moment to think about where that 2 is at. Is that 2 located on the end as an addition or subtraction? No. If it was on the end, that would move it up or down. Is that 2 inside the parentheses? No. That would move it left or right. Where is the 2 at? The 2 is in front. Now what that's going to do is that's going to double the y values, okay, because it makes it times 2. So the x values are going to stay the same. It's going to double the size of this graph. If it was a 3, it'd make it 3 times as much. If it was a 1/4, it'd be way smaller. So that's going to make this graph twice as large because the 2 is in front. So the x components stay the same. The y components are going to change. So this is going to double the y values because of the 2. So we're still at negative 2, but instead of it being at negative 2, 2, it's at negative 2, 4. And the other point, instead of it being at 2, negative 2, we have to double it on the y part, and that's going to make that now at 2, negative 4. And now when I connect these together, look at what has happened to your picture. You've doubled the size of it. If it was a negative, you would flip it over. This one is doubling it. The 2 makes it double in size. So you keep the x component, you double the y value. Okay, let's look at, how about another logarithm question? And again, I'm just picking random ones that I think we may want to review. I'm going to work all of these out and post the work in Canvas this afternoon. Let's look at question 36. And we went over these last class period. So this is what we're going to look at here. What do I need? Well, I need to make sure that I can solve it for x. X is located as an exponent. So I need to make sure that my bases then are the same. Now, if I look at 16, I can't make 16 come out to be that 64 because 16 squared is already too big because 16 squared is 256. However, 16 is a perfect square of 4, right? So 16 is 4 squared. Why is that going to be important? Well, if 16 is 4 squared, what's 4 cubed? 4 cubed is 64, right? That's going to give us a common base because 64 is 4 cubed. So now we can rewrite it with our new common base. So our common base is 4. So that means this one is going to be 4, and we bring that 3 up because that's 64. So 4 cubed is 64, so that's going to be a 3, and it has to multiply it by x minus 1. So there's that piece. The other side is 4 squared because 4 squared is 16. So that's 4, and then bring that 2 up. 2 times a 3x there. Now look what we have done. Now we have a common base, don't we? Right? Common base is 4. So we can solve it by setting the exponents equal. So what are we going to solve? 3 times x minus 1 equals, I'm going to go ahead and multiply those together, so that gives you a 6x there. Now it's a simple matter of distributing and solving. So not much to this, because that's going to be then a 3x minus 3 equals 6x. We'll move that 3x over. And I'm going to rewrite it in the right order. So moving that 3x over, that's going to leave you with a 3x equals negative 3. Divide by our 3. So now we've got it. So x equals now a negative 1. Pretty simple. Okay, let's see if we can figure out how to solve question 39.